Welcome to day 39 Working with Asynchronous Programming. In this session, we will dive into the concepts of asynchronous programming in Python using async, async, and await. Let's explore how these tools can help us manage concurrent tasks efficiently. To start, let's understand what asynchronous programming is. Asynchronous programming allows multiple tasks to run concurrently without blocking the main program flow. This is particularly useful for IO-bound tasks such as making web requests or reading and writing files, where the program does not need to wait for one task to finish before starting the next. Now, how does Python's async module make this happen? It uses an event loop to manage and schedule asynchronous tasks. By using async and await, Python allows us to write asynchronous code without manually handling threads or processes. Let's see how this works. Here are some core concepts in async that we need to understand. First, coroutines. These are functions defined with the async-def syntax. Coroutines can pause their execution using the await keyword and resume once the awaited task is completed. Next, tasks. A task is essentially a coroutine that has been wrapped in a way that allows it to run concurrently with other tasks. Finally, the event loop. The event loop runs in the background and schedules these tasks. It allows one task to execute while another is waiting for something, like IO operation to finish. Let's look at a simple example of how Asyncio works. In this example, we have two tasks, task 1 and task 2. Both tasks start running concurrently. Notice how we use await asyncio.sleep to simulate an IO operation. This non-blocking operation allows task 1 to run while task 2 waits for 1 second before finishing. Meanwhile, task 1 continues its execution and completes after 2 seconds. When we use asyncio.gather, both tasks are executed concurrently. This ensures we don't waste time waiting for one task to finish before starting the other. Now let's break down the async and await keywords. The async keyword is used to define a coroutine. It tells Python that the function is asynchronous and will contain await expressions. Inside these coroutines, you can use the await keyword to pause the execution and wait for another asynchronous operation to complete, such as IO or time delay. In this way, async and await allow us to manage concurrency in a very intuitive way. Let's apply this to a practical example, building a simple web scraper. In this code, we use the AIO HTTP library to make non-blocking HTTP requests. Each URL is fetched concurrently using asyncio.gather. By using asynchronous programming, we avoid waiting for each request to finish one by one, making the scraper much more efficient when dealing with multiple URLs. Now let's talk about error handling in asynchronous programs. Just like in regular Python functions, we can use try and catch blocks inside coroutines to catch exceptions. If an error occurs while one task is running, it will be caught by the except block. However, remember that uncaught exceptions will propagate to the event loop and may stop other tasks from executing. Asynchronous programming is not only for web scraping, it's widely used in real-time applications such as chat applications or multiplayer games where multiple users interact with the system at the same time. Web scraping, where we make multiple non-blocking requests to gather large datasets quickly. IO-bound tasks like downloading files or interacting with databases where asynchronous programming can significantly improve performance by not blocking the main program. To recap, Asyncio helps us manage concurrency in Python by using coroutines and an event loop. Coroutines are defined with async_def and we use await to pause execution until another task completes. Asynchronous programming is ideal for IO-bound tasks where it helps us handle multiple tasks concurrently without blocking. This approach allows us to write more efficient, responsive, and scalable programs, especially when dealing with tasks that involve waiting, such as network operations or file I/O. This concludes our session on asynchronous programming. I hope you now have a clearer understanding of how to use asyncio, async, and await to write concurrent programs in Python. Keep practicing and you will be able to apply these concepts in real world applications.